So in this video we want to use the law of cosines to solve a side-side-side triangle, or a triangle where we know three sides but no angles. So just like the previous video, we first want to start by drawing a triangle. We don't worry about whether it's to scale, whether it's obtuse or acute. We just get ourselves a nice picture to look at. So triangle ABC, so capital letters representing the angles, and then we're given the side lengths a, little b, little c. So we have 450 centimeters, we have 208 centimeters, we have 382 centimeters, but we aren't given any of the angles, big A, big B, big C, so we're going to need to approximate those. And over here I'm going to go ahead and label things in. So side A is across from angle A. Side B has to be across from angle B. So 208 goes right there. Try it again. Little b equals 208. And then little c has to be opposite angle C. So little c is 382. And because we know three sides but no angle, we're going to have to use the law of cosines to solve for one of the angles. And in step 2, to solve for a second angle, it would be nice to be able to use the law of sines, because the setup and calculation is a little bit simpler. And so this leads us to a little bit of a subtlety. So if we're using the law of cosines to solve for an angle, we're going to need to take the cosine inverse at some point in the process. And what we want to remember is that the cosine inverse can give us angles on the interval from 0 degrees to 180 degrees. It's the only angles it can give us. If in step 2 we want to use the sine inverse function, what we need to remember is that the sine inverse function only gives angles between negative 90 degrees and 90 degrees. And just like the previous video, then the bottom line is that if we try to use the sine inverse to calculate an obtuse angle, we won't get it. What we'll get is the supplement of it. We'll get the acute supplement of the obtuse angle. So if we're going to use the law of cosines in step 1, we want to use the law of cosines applied to an obtuse angle, or the only angle that is a candidate to possibly be an obtuse angle. And what we want to remember is the same thing we did in the previous video. If there is an obtuse angle, it has to be opposite the longest side of the triangle. So in this case, I look at the three side lengths. It's clear that 450 centimeters is the longest side length, which means if one of the angles is obtuse, angle A has to be the angle that's obtuse. So when I use the law of cosines in step 1, I'm going to solve for angle A, which is the only candidate on this triangle to be an obtuse angle. And then once I've found the obtuse angle, if it exists, I'm okay to use the inverse sign to find the other angles, because if one angle is obtuse, the other two must be acute, and the sine inverse finds acute angles because acute angles live on that interval from 0 to 90 degrees. So I'm going to set up the law of cosines. Remember, the law of cosines, you start with the side that's opposite the angle you're working with. So if I want to find angle A, I'm going to start with the side opposite that angle. So it's going to be A squared equals, and then it's the sum of the squares of the other two side lengths. So it looks like the Pythagorean theorem, minus the tweak factor because it's not a right triangle. So 2 times b times c, it's always going to be minus twice the product of the two sides here, times the cosine of the angle that's opposite the side you're working with. So these guys, the angle here goes with the side that's right here. And so once I have this, I can go ahead and load pieces into this thing. So we know that a squared is going to be 450 squared, and that's going to equal b squared, which is 208 squared, plus c squared, which is 382 squared, minus 2 times b, which is 208, times c, which is 382, times the cosine of the angle I'd like to find. And then what I can do next is then solve for the cosine of A. So if I want to get the cosine of A isolated, what would I need to do to isolate this? Well, I'd have to subtract 208 squared from both sides. I'd have to subtract 382 squared from both sides. So right here I would get the 450 squared. All I did was lever things around the equal sign to get my cosine on this side. So I get 450 quantity squared, subtract 208 from both sides because we're trying to isolate this guy right here. So minus 208 quantity squared, subtract the 382 squared from both sides. And once we subtract those from both sides, this piece right here is going to be by itself. And to isolate the cosine of A, we'll need to divide by this stuff here. That's going to be the coefficient on A. So it's going to be divided by negative 2 times 208 times 382. Notice we could have just done it with the formula. When I had the A squared equals B squared plus C squared minus 2BC cosine A, before I even plug the numbers in, I could isolate the cosine of A. I could say, hey, the cosine of A is going to be, I have an A squared, subtract B squared and C squared from both sides. A little easier than doing it with numbers. Once those are subtracted from both sides, I'm going to need to divide by the coefficient on cosine A. And then once you do that, then you could just load the formula with the numbers that you see in your diagram. So that would be another way to do it, so you don't have to drag the numbers around with you like I did here. And then once you do this, you're going to take the cosine inverse of both sides to get A by itself. So we wind up getting A equals the cosine inverse of both sides. And then when you do this calculation in the calculator, the cosine inverse of that's going to come out to be, and I carried it out to 6 decimal places, it's going to be 94.805276. So because I'm going to use this angle to do additional calculations, I want to carry out my intermediate calculation to at least 6 decimal places. But that's not going to be what I do up here when I report it. I'm going to approximate it at most to the nearest tenth. I wouldn't do more than that. We could make an argument for even going to the nearest degree. I'd approximate it here, but use 6 decimal places for my next calculation. And we can see that we did get an obtuse angle, just barely obtuse, which makes sense because the side lengths are fairly similar in size. I made this just long enough to make angle A obtuse, and I did it on purpose. Notice that it didn't have to be obtuse. If I made this a little bit smaller, like 430, and I ran through the same calculation, I'd get an angle like around 89 degrees. I'd get something just a little less than obtuse. But the idea is now I have an angle and the side opposite the angle. So once I know this angle right here, this is 94.8 degrees about. I know the angle and the side opposite the angle. I can use the law of sines. I can say, hey, the sine of an angle, 94.805276 degrees, divided by the side opposite the angle, 450, can be used to set up a ratio. And here I can solve for either B or C. They're both acute angles. Because this one was obtuse, it doesn't matter which I do. So I could try solving for angle B by saying sine of angle B over the side opposite B is the 208. And then we would multiply both sides by, I'm going to give myself a little bit of space, we'd multiply both sides by 208 to get the sine of B by itself. And then we would take the sine inverse of both sides, which would cancel the sine function, giving us our angle B. And then we can approximate this, and now we would go directly to the nearest tenth. And when I did this, I got 27.4 degrees is about B. So I get 27.4 degrees here. And once I have the two angles, I know the sum of the angles of a triangle is 180. So I'm going to take the 180 total degrees of my triangle and subtract off the 94.8 degrees and subtract off the 27.4 degrees to come up with my last angle, which came out to be 57.8 degrees. 57.8 degrees. So again, fairly straightforward process, but there is that subtlety in the first step where, because you're using the law of cosines, you want to go hunting for the obtuse angle first, so that in the second step you can use the sine inverse without having to worry about getting the wrong angle.